Hi everybody, Mrs. Pesic here. We are looking at section A.5, which is called solving equations. The definition of an equation in X, it's a statement that two algebraic expressions are equal. Here are a few examples of equations. We have 5x squared minus 6 equals 2x, or square root of 2x equals 9. These are examples of equations. To solve an equation in X means to find all values of X for which the equation is true. All right, and so the solutions are going to, well, the values of the x that make the equation true are called solutions. So for example, if you have x squared equals 16, then 4 and negative 4 will be the solutions. In this section, we're going to be solving lots of different kinds of equations. Take a look at this example. X squared equals 3. Now that would have no solution if we only wanted to look for rational number solutions, but it does have two solutions if we're willing to just say any real number can be solutions. So square root of 3 and negative square root of 3 would be the solutions for that equation. An equation that is true for every real number in the domain of the variable is called an identity. You know, if I'm going too fast, you can always stop, pause, rewind. An equation that is true for every real number in the domain of the variable is called an identity. So here's an example of an identity. X squared minus 4 equals x plus 2 times x minus 2. That equation is true no matter what we plug in for x. So for every single real number that we would plug in, you can plug in 5 for x's, you could plug in 12 for x's, you could plug in negative square root of 3 for x's, and they're always going to be the same on both sides. So that makes that an identity. An equation that is true for only some, or maybe even none, of the real numbers in the domain of the variable is called a conditional equation. So here are some examples of conditional equations. 2x minus 1 equals 5x. You know how to solve an equation like that, and we are going to end up getting one solution. Here's another example of a conditional equation. 2x minus 1 equals 2x plus 6. Now with this one, you know that if we subtract 2x from both sides, we're going to end up with negative 1 equals 6, which is never true. So that means that this equation, 2x minus 1 equals 2x plus 6, has no solution, but it's still considered a conditional equation. In this section, as I said, you're going to learn to solve many different kinds of conditional equations. Let's take a look at the first kind. First kind would just be solving a linear equation like this. So if we were going to solve this conditional equation, we would distribute the 2 and distribute the negative 3, and we would then combine like terms. I'll add 6x to both sides. I get 8x here. I'm going to add 8 to both sides also, and I would get 8x equals 11, so x would equal 11/8. And if I did not do that correctly, I'm sure that you will let me know. And of course, you could plug in 11/8 to see if that is correct. To solve an equation with fractional expressions, you would want to find the least common denominator of all the terms and multiply both sides by that least common denominator. So here's an example. This is a fractional equation. It's got some fractions in it. So what we want to do, instead of trying to get a common denominator for every single fraction, just find that least common denominator. In this case, it looks like it's going to be 4, and just multiply both sides of the equation by that least common denominator. So if I do that, I'm distributing the 4 now, I would get 5x plus 2 equals, distributing the 4 over here, I get a 4x minus 2. And then we would subtract 4x from both sides, and we would get x plus 2 equals a negative 2, subtract 2, and we get x equals negative 4. Again, you could plug in negative 4 here and see if you get a true equation. All right, let's try this example. Here's another rational equation to solve. In this case, it looks to me like the least common denominator for this problem would be x plus 4. So instead of trying to get every single fraction here to have x plus 4, since it's an equation, we're allowed to take both sides of the equation and multiply by x plus 4. So if I multiply both sides by x plus 4, I will get, again, I've got to distribute, so I'm really multiplying this by x plus 4 and this by x plus 4, and this times x plus 4. So I'll end up getting x plus 4 plus 2 times x plus 4, if I distribute the 2 here, equals 0 times x plus 4 is still 0. So I get x plus 4 plus 2x plus 8 equals 0. Combining my like terms here, I get a 3x. Combining these, I get a 12. And I end up getting 3x equals negative 12 and x equals negative 4. Now, by all means, do a check. So you want to plug in that negative 4 in for x wherever you see an x. So I need to plug in negative 4 here, and negative 4 here, and negative 4 here. Do you see a problem with this? Well, sure. If we plug in negative 4 wherever we see an x's, we're going to end up with 0 in the denominator. So this answer here actually is called an extraneous solution. Extraneous, that's supposed to be a US, EOUS, extraneous solution, meaning that negative 4 will solve this equation here, but it doesn't solve the original equation. So you always want to check your work, especially in this section. All right, so let's take a look at quadratic equations. Ax squared plus bx plus c equals 0 is the general form. A, b, c are real numbers with a not equal to 0, also known as second degree polynomial equations. So we're going to be solving these, and we're going to be solving them in multiple different ways. So here are the different ways to solve quadratic equations. You can solve by factoring. You can solve by taking square roots. You can solve by quadratic formula, and you can solve by completing the square. So those are the 4 different ways that we're going to be going over on how to solve quadratic equations. Let's start with the factoring. If you want to solve quadratic equations by factoring, you're going to solve x squared minus 10x plus 9. And you know how to factor this. You can use product sum if you'd like. Product is 9, sum is negative 10, and the 2 numbers that would work would be, let's see, 9 and negative 9 and a negative 1, I believe, and so forth. And if you do the product sum technique or the guess and check technique, you will end up with 9 here, 1 here. I think they both need to be negative. So we have this. So we've factored it, and now we would use the zero product property, which basically says if you have 2 things being multiplied together to give you 0, then one of them had to be 0. So either x minus 1 equals 0, or x minus 9 equals 0. Solving each of these individually, we get x equals 1 or x equals 9. All right, as our solutions. And again, you could plug those in to check them. All right, that's an example of solving quadratic equations by factoring. All right, what about solving by taking square roots? Let's try that one. If we're going to solve by taking square roots, notice we have the equation and it's set up differently. We've got 3 times some quantity squared equals something, and this is a good setup for solving by taking square roots. I would start this problem off by dividing both sides by 3. So we get x minus 2 quantity squared equaling 3. And then I would take the square root of both sides because we want to undo the squaring. I would not multiply this all out and say this is x squared minus 4x plus 4. Don't do that. That's going to be going backwards. All right, that's not going to really help you very much. We've got it already nicely solved, or I should say nicely factored here. So it's something to the squared power. So we're going to take the square root of both sides. But whenever you take the square root of both sides of an equation, you need to remember that you could have a positive or a negative. All right, so you need to throw on a plus or minus. Now the square rooting here, the square rooting and the squaring are canceling each other out. So we just have x minus 2 on the left equaling plus or minus square root of 3 on the right. Last step, add 2 to both sides. So we would get x equals 2 plus or minus square root of 3. And those would be our 2 solutions to this equation. 2 plus square root of 3 would be one solution. 2 minus square root of 3 would be the other solution. All right, so that's how to solve quadratic equations by taking square roots. Okay, now what about solving by quadratic formula? If we're going to solve by quadratic formula, and I believe you are already familiar with the quadratic formula, you know it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so to solve this equation here, we need to note that a is 2, b is negative 4, and c is negative 5. So we're going to plug all those values into our equation. So we're going to get x equals opposite of b, so that's opposite of negative 4, plus or minus the square root of b squared, that's opposite of b, I'm sorry, that's opposite, negative 4 quantity squared, so make sure you put the negative 4 in parentheses, minus 4 times 2 times a negative 5, and this is all over, the whole thing has to be over 2 times a. That's over 2 times 2. So working this one out, we would end up with positive 4 plus or minus square root of, looks like negative 4 times negative 4 is a positive 16, and we've got 8 times 5 is plus 40, and this is all over 4. Can I divide out this 4 with this 4? Well, no, because this 4 right here is a term. It's being added to the radical. It's being added. It's not a factor. All right, so we're going to get rid of that. Dividing out, can't do that. All right, but what we can do is, we lost our page. There it is. What we can do is write this as 4 plus or minus square root of 56 over 4. And then we could simplify square root of 56. Side note, how do we simplify square root of 56? I believe that is square root of 4 times square root of 14. Is that right? I think that is. So that we would have 2 times the square root of 14. So that means we really have x equaling 4 plus or minus 2 square root of 14 over 4. And we can write that as 4 over 4. We can split this up into 2 fractions, 4 over 4 plus or minus 2 rad 14 over 4. And now we can reduce these individual fractions. Now I can say, oh, 4 goes into 4 once and into 4 once, 2 goes into 2 once and into 4 twice. So I think our final answer would be 1 plus or minus square root of 14 over 2 as the answer to this problem. All right, we're going to stop there for this video, and you're going to do some homework problems that are related to solving linear equations, solving fractional equations, and solving quadratic equations using factoring, taking square roots, and quadratic formula. We'll handle that last part, which is the solving by completing the square. We'll do that together next class. All right, so thank you for watching, and check what the homework assignment is on the website. Thank you.